You guys have a good weekend? Yeah? Anyone get engaged? Anyone break up? Anyone wish they broke up or wish they got engaged? So, we did learn that Michelle became a grandparent over the weekend. I asked if anyone had anyone had a grandbaby, and she raised her hand, but it was about something else. So she's not that old. So yeah. Anyone get a mission call? Anyone's friend get home from a mission? So. Anyone find a good math problem to geek out about? I did. We might geek out about it later, some other day. It's cool. How many of you are going into like computer animation? Anyone doing computer animation? Oh, he was. So, robotics. Anyone doing mechanical engineering and robotics? Oh, great. The thing we might do has application for robotics too. But, anyone have a date night where they watched Brother Corey videos? If you did, I feel really sad for you. So. Yes. Does it count if you watch it? Well, you're forced to do so. So not really. So, I can't get my wife to watch them, so not judging if you can't get anyone else to watch them. I can force you guys to watch them. Oh, I can offer incentive for you guys to watch them. I can't really force you anyway. But okay. Yes. Oh, you bet. Okay. Let's get started. Who'd like to offer a prayer for us? Anyone? Go ahead, Jordan. Here, I'll bring the mic over.
Father in heaven, we come before you this time and give you thanks for the day which you've been given. We're grateful for the time which we had to spend here in learning algebra. We ask for that Spirit to be with us, to be able to help us understand the material which we cover, and to be able to help guide Brother Corey and the things that he shares with us and teaches to us. We're grateful, Father, for thy Son, Jesus Christ, and ask for his Spirit to be with us as well. And we're grateful for these things and say these things in the name of thy Son, Jesus Christ. Amen.
Amen. Thank you. So there's some problems up here. So a lot of days we'll start with problems like this, and I'll turn you loose and see how much you can do, at least for a few minutes, and then as we solve them as a class, we might not get through all of them, but as we work on them in the class, I'll work on using them to answer the questions that you have and teaching other important ideas. So it's nice to take a picture of these because these might be disappearing once I get up to the board. So if you want to have a record of these so you can be working on them, especially if it's stuff, if I'm going through stuff you already know, you can pull these out and be working on them and practicing. So last time we didn't get to number 4. 4 is actually a homework problem. So, but 1 or 2 are much more interesting. So questions. What questions do you have on 2.1 and the beginning of 2.2 that you read about? Okay, solving systems of equations should be something you should have all seen. How many of you have done row reduction with matrices before? Okay, more in this class than the last class, but okay. But still less. I thought for sure half of you guys would have seen it, but they must not teach it anymore. or let's not teach it much. So any questions on the content of 2.1 and 2.2, the first part of 2.2? Okay. Oh, yes.
The simple reason why we want to do like row reduced echelon form is to solve systems of linear equations.
Okay. So that question for those online is really the main reason we want to get them into reduced row echelon form is to solve system of equations. That's the main reason we're doing it now, but it also turns out to be really valuable for us later in other things also, as we get further into understanding matrices. So I remember thinking, when I had this, it was a chapter in college algebra when I had college algebra in high school, and we learned to row reduce. And all I remember about matrices, all I remember at the time was thinking matrices are just a harder way to solve system of equations, and that there's no reason why you should ever have a non-augmented matrix, because we only, I mean, you're just using matrices to solve system of equations, so you should always have an augmented matrix. I was wrong on both counts. Well, it's still, by hand, it still may be you may feel like it's a harder way to solve systems of equations, but there's lots of other things to do with matrices that are worth studying. So, but yeah, this will be a tool we will use through the whole semester. Probably 2/3 of the sections from here on out, we will probably be using this as a way to understand the relationship in the vectors and the rows of a matrix, and using that for some reason. Okay, other questions? Okay. So go ahead, dive in, see what you can do in trying to get number 1, number 2 into reduced row echelon form the best you can. You can work with a neighbor for sure. Go ahead, you can make mistakes. This is a great time to work and make mistakes, so then when we go through it in class, you can see where your thinking was right and where your thinking was not so good. Okay. There is a nice pattern that we can use that works, but there are other ways. So you might do something in a little bit different way, and it still works on these. So that's certainly possible. So go ahead and work on these for a little bit. Okay, let me have your attention up here. This is, let me explain a pattern that works really well and keeps you from having to do a lot of thinking, although sometimes this, there's some other strategy you can use that make it so you can skip some computation. But first thing, if you're trying to get ones in a spot, then to get ones, you want to swap rows or multiply a row by a constant. Okay, those are the two strategies that work really well for getting ones. Okay, and if you're trying to get zeros, then use the row operation of adding a multiple of one row to another row. Okay, so if you're trying to get a spot, if I'm trying to get this spot to be 0, I'm going to use another row where I have a non-zero and multiply something by this row to add it to get that to be 0. Okay, this is the order that we tend to go in. It doesn't always work because you might have to swap, or sometimes you might not be able to get this to be a 1 because it might be a 0 or other things. But so in general, you want to start up here and make this a 1. Then you use that 1 to get zeros here and here. So you can multiply, if this was a 5, then this was a 1, I could multiply this row by a -5 and add it to this row, and then it would be a 0. And if this was a -3, then I could multiply that first row by a -3, by 3, add it to this row, and now that's a 0. Okay? So that's his first thing, get this to be a 1. Second, get this to be a 0. Third, get this to be a 0. Fourth, you want this to be a 1, if you can. It might not be possible. You might end up with both zeros right here, and you might be stuck, and you can't make that a 1. But if possible, you make this a 1, and then you use that 1 to get this a 0. Here, I should do. And then you make this a 1. So by multiplying by, usually you'll end up multiplying by a non-zero constant. Like if it was a 5, you multiply the row by a 1/5. And then you use that to get those 0, and then you use that one to get that 0. So that's the general pattern that we follow. Okay. So with that, let me give you guys another couple more minutes to work on that first problem. And once you solve 1, go answer number 3. So I should have put that as number 2. But you use the answer from 1 to answer question 3. Okay, I'm going to start going through this over here. I've already started going through this over here. So, so I already had a 1 here in this upper left-hand corner. So, so that was nice. And now I'm going to use that 1. I'm going to use that 1 to get these zeros right here. So I multiplied this row by a -1 and added. And so I get a -1 plus 1 is 0. A -1 plus 1 is 0. 0 plus 1 is 1. A -1.5 plus 1.75 is 0.25. Okay? So I was after a 0, so I used that, add a multiple of one row to another row operation, got that to be 0. Now, I can do it again. So I want this 1 to be a 0, so I'm going to add, I'm going to multiply this first row by a -1 and add it to this row. So, so you multiply by a -1 and add, that becomes 0. I get a -1 plus a 2, which becomes 1. 0 plus a 2 is 2. A -1.5 plus 2.65 is 1.15. Okay, we good so far? This is going to be the main thing we focus on this whole week. So we'll just be, you'll be watching a video more about this stuff, and we'll be doing, you know, in preparation for Wednesday, and we'll be doing more of this Wednesday. So now I wanted, now the next thing I want is a 1 right here, if possible. So I'm going to swap these rows to get a 1 right there. So that's what I did. If these two are both 0, I'm kind of toast. I'm not going to do anything to this line. I've already got, it's already got a leading 0 up here. I mean, a leading coefficient up here where I want it. So if these were both 0, then I'd move over to here and make this one a 1. So that would be my next leading, my leading entry. So, but I do have a 1 down here, so I'm going to swap rows, make it a 1. And it's already made this one a 1, and I've already made this a 0, so it saves me some work. Now I'm going to use this 1 to get this 2 to be a 0. So I'm going to multiply this bottom row by a -2 and add. So that's what I started to do here. But 0, no matter what I multiply it by, plus 0 is 0. 0 plus 1 is 1. I get a -1 times a -2, which is a -2, plus the 2 is 0. The whole reason I multiplied by a -2 was to make that 0. And now I'm going to multiply this by a -2, which will be a -0.5, and add it to 1.15, and that becomes 0.65. Is that right? Is it 0.65? Yeah, 0.65. Now, this is already 0. Well, let me just rewrite this one up here. 110, 1.5. You wear out a lot of pencils with pens doing row reduction. So, and you need to be careful because it's easy to make a mistake. Keep track of the operations. You can see a lot of this you do in your head, and so it's easy to lose track of things. So check your work. Especially if you start getting really crazy stuff, you're like, maybe I made a mistake somewhere. So this is already a 0, that's nice, but I want this to also be a 0, so I can use this 1 to get this to be a 0. So I'm going to add a negative row 2 plus row 1. So then that will make that 0. So if I multiply this by a -1 and add, I get a 0 plus a 1, which is a 1. A -1 plus a 1, which is a 0. 0 plus a 0 is a 0. A -0.65, 1.5. What does that get me? 0.85. Right? This is 2.75. So if I go up a 0.1 and down a 0.1, then I get 0.85. 0, 1, 0.65. 0, 0, 1.25. Okay, and we're good. The reason this is nice, we can read off exactly what x equals, y equals, and z equals. We've changed the set of equations. This has equivalent information to our original, except this is more meaningful to us. Okay? This is x equals 0.85, 1 equals 0.65. I'm sorry, y equals 0.65, z equals 0.25. Has anyone solved problem 3? What have you got, John? Okay, x equals, sorry, didn't mean x equals. So x plus 100y plus 100z equals, what is it? 90.85. Okay, so what John just calculated for us, and what this work helped us to do, is find out the price of this hamburger. That is a 100 by 100 at In-N-Out. So if you know about In-N-Outs, you can order a 2 by 2, which is a double double, and a 3 by 3, which is 3 patties and 3 cheeses. Did the patties come first? Anyone know? Okay, well, luckily a 100 by 100, it's the same. But yeah, you could order a 3 by 1, which is I think 3 patties and 1 slice of cheese. So someone went in and ordered a 100 by 100. And so yeah, I don't know, I think it's sick, but I have a kid that would love that. He loves In-N-Out. But look at this sign over here. Can you see where our systems of equations come from? So look at this sign, figure out where the system of equations comes from, and tell me what x equals and what y equals and what z equals. Looks like we have a few people that have figured this out. So I think Kevin had his hand up first over here. So Kevin, tell us what it is. Yeah, I think those are swapped, but it's, yeah. So this is the patty, and this is the cost of a slice of cheese. So nice. Is that what other people got? So yeah, technically you could say X is the price of the bun and any toppings. But yeah, so a hamburger has a bun, 1 patty, cheeseburger, bun, patty, and a slice of cheese. The double-double has a bun or bun and toppings, 2 patties, 2 slices of cheese. And we actually have the picture of the receipt to see how well we did. So we got 90.85. There it is, 90.85. This is from 2004, so this is old. These old prices. That's why they're cheaper than you expected. So it's on Halloween. I noticed in the last class. This is Halloween 2004. So if you knocked on the right door in Las Vegas, this was in Las Vegas. If you knocked on the right door in Halloween, Las Vegas 2004, you could have got that as your treat. So, okay. Questions? Questions about In-N-Out and their secret menu? No, I'm just kidding. I don't know very well. I know there's a Flying Dutchman. That's a special order. There's a animal something. I don't know. Look online. It's not secret anymore. Okay. So any questions on the row reduction here? Okay. Let's go back here, and why don't you guys start on number 2. have faith in this. The math isn't that bad. Keep things in fractions. Works out better than it should. So, well, I don't know. I only went to eighths when I was doing this. So, do you have fractions that are more crazy than eighths?
Right now, like I'm doing good, but I'm
Oh, that's
scared for
awesome.
the
Yeah.
next one.
Well, what are you going to do?
I don't know. So-
All right. This actually comes from a context also. It's not a food context. Anyone want to take a guess? I'll give you a hint. This is beta. Someone said software. It's not software. Anyone else know beta? Where they use beta? Okay, so this is these are three stocks, three UTFs, exchange traded funds. This follows the NASDAQ. SPXL is just a triple leveraged fund. It follows the S&P 500, but it's a way to lose your money really fast. And you know what it takes to make a small fortune in the stock market? A large fortune. So, okay, so this is a real estate fund. It doubles the real estate, a real estate index. And the idea is, I'm going to make a portfolio. Oh, and beta is a measure of risk. The smaller, the better. Okay, so this 3 is like really bad. 1 is about the level of the stock market in like S&P 500. So that's why this is 1. It's follows closely with the stock market risk. But this is like really high. So this is my goal. I have these 3 stocks I can buy. The question is, how much of each of these do I buy so I can get a return of 21% in the year and with a risk of 1.5 beta. So this is my goal. Okay. So how many solutions am I going to have to this system? I can already tell without solving, I already know something about this system. Yes? There are going to be infinitely many solutions, he says, because I'm going to come out with a line. What do you mean by a line? Okay, so he says, for those online, he said, you're not going to be able to solve for all of your variables because you need at least three equations for these 3 variables, right? And we've only got 2. Yeah, so nice. Yeah, so we've only got 2 equations. If we wrote these out as equations with 1x plus 3y plus 3 halves z equals 3 halves, if we wrote them out that way, you'd recognize them as equations of planes. I would hope you would recognize them as equations of planes. So the solution is we're finding we're finding where those 2 planes intersect. If there's an intersection, they could intersect and be the same plane, and then there's infinitely many solutions, and it's not a line. But they could intersect at just a line. So we're going to have infinitely many. We have 3 variables. We've only got 2 pieces of information. The best we can do is solve for 2 of them in terms of a third, and that's what we're going to end up doing. So there is a way, by the way, we could actually add a constraint here and make it so we could solve for x, y, and z. And that constraint, which I doubt we'll get to today, you can add that x plus y plus z has to equal 1. So we could add down here that just 1, 1, 1, 1. And what that is that all of your money has to add up to 1. So x and y and z would just be the proportion of all the money you want to invest in each of those funds. So you could add a constraint, and then, yeah, then you can go ahead and start solving, and you can actually find what X, Y, and Z are. It's not that hard, and even though we got some fractions in here, it's not that bad. Okay, let's do this. So I wanted this to be a 1. There's two things that I could do. One, I could divide by 22 on that whole row. Why was that a bad strategy? Because, yeah, I don't want to deal with those fractions. At least this one I could go down to 11ths in the denominator, but here I'm stuck with 13 20-seconds, 21 20-seconds. I have another option. I could just swap rows here. So that's what I did. So I have a 1. Now I'm going to use that 1 to make this 0. Okay, this is a pivot position. Okay, I've got a pivot position here. I'm going to use that pivot position. In reduced row echelon form, all of the other entries in a column where there's a pivot position have to be 0. So the pivot position will be 1. All other entries will be 0. So I have a pivot position. I'm going to use it to make this 0. So I'm going to multiply by let me just rewrite this first row. So I'm going to multiply the first row by a negative 22 and add it to the second one. So a negative 22 plus 22 is 0. Negative 22 times 3 is going to be a negative 66 plus 34 is 32, negative. Negative 22 times 3 halves, that's 1 1/2 22s. Half of 22 is 11, so 3 11s is 33. So a negative 33 plus 13 is a minus 20. And I get a negative 33 plus 21 is a negative 12. Okay. Questions? Okay. I want this to be 1. This is a new pivot position. This is row echelon form. Okay. I have two pivot positions. All of any pivot positions in a row above it is to the left, and that's pretty much all there is to row echelon form. The echelon part. Okay, so something like this. This is in echelon form. Okay, the zeros make a nice staircase there. So echelon refers to levels, comes from the same word as escalator or escalera in Spanish. So, okay, so you get that. This is what we're shooting for. You could have another row of zeros there, that's fine. If you have columns of zeros, they go to the left. So that's echelon form. Reduced row echelon form is more. Reduced row echelon form takes the pivot positions. Where are the pivot positions? Here, here, and here. I have 3 pivot positions. It turns those into 1s. So I want to make each of those 1s, and then all of these other ones have to be 0 that are in the same column as the pivot positions. So that is reduced row echelon form. And the pivot positions are important because they say something about the solution of the system. They also help us with other things. Okay, people are falling asleep, so let's get moving on. Okay, we should throw them down the escalera. I'm just kidding. That's mean. Okay, I'm trying to learn Spanish, so I'm just using my Spanish, that's all. Okay, so I want to get this to be 1. So easiest way to do that is to multiply by negative 1/32. So a negative 1/32 times row 2, and that gets me 0, 1. So 20 32 will simplify to 5/8. And 12 30-seconds will simplify to 3/8. Okay. And then, oops. And I'm only one step away from reduced row echelon form. I have to get this 3 to be a 0. There's nothing else I can do over here. All I do is I work with the pivot columns, and then whatever else is left is what is left. Okay. In this case, we're going to have a free variable. Well, let's finish, and then we'll go from there. So this was my second row. And so I want to get this position where the 3 is. I want to make it a 0, so I'm going to use this 1 to get it to be a 0. So I'm going to multiply by a -3 this whole row and add. So a -3 times 0 is 0, plus 1 is just 1. A -3 times 1 plus your 3 gets me 0. It's the whole reason we multiplied by that -3 is to get that 0. We have 5/8 times a -3 is a -15/8. -15/8 plus 3/2. 3/2 in terms of eighths is 12/8. So I have a -15/8 plus 12/8. That leaves me with a -3/8. And then a -3 times 3/8 is a -9/8. -9/8 plus 12/8 is 3/8. Did I do that right? Okay, I hope so. And this is as far as I can go. This is reduced row echelon form. I have 2 pivot positions, 2 pivot columns. Then I have, these are whatever they are. This, I have X, Y, and Z. This is what we will call a free variable. Okay, there's more on free variables and solving for free variables in the next, in 2.2b. Yes, Seth?
Is that the same or different than a slack variable?
A slack?
Yeah, I was taught that column was a slack variable.
I haven't heard the term slack, but there are other terms like independent variable, sometimes they're called. But yeah, so maybe, I imagine so. So we tend to call them free variables in this class. So we can solve for x and we can solve for y in terms of z. Z is a free variable. We can pick z to be whatever we want it to be. And then, but once we pick z, then x and y are determined. So they're not free. So we can represent the solutions. We're going to rewrite this as a system, and then I could rewrite this as x minus 3/8 z equals 3/8. That's what that represents. And then this is y plus 5/8 z equals 3/8. So I can use these to solve for x and y by pulling the z's over. And z, it's a free variable. I say I'm just going to let z equal z. Z is equal to whatever it is. And then we can rewrite this in vector form. So let's pull these over to the other side. So I get x equals 3/8 plus 3/8 z. Y equals 3/8 minus 5/8 z, and z equals z. Now we have a parametric form. Let's put it into vector form. So I can rewrite that as x, y, z. So this might be brand new. This might be the first time you see that, like going all the way through a full free variable to the solutions. There's more on this on the pre-video, if I remember right, for next time. So 3/8, 3/8, 0. This is the point it goes through. The constants over here on the right. And then I'm going to have z times, I'm going to pull out my z, and I get the direction vector 3/8, -5/8, 1. So now this is the equation of the line. This represents the line where these two planes intersect. So any point on that line is a solution to this equation. It might not work in our context. In our context, we need x, y, and z to all be positive. And you could start throwing in values for z. You could say, I'm going to buy $1,000 of the URE stock, and so the z is 1,000, and then you could solve and figure out how much money you'd put in the other ones to get that goal. So it's a little slicker if you add on the 111. Then you get just percentages, and you know which percentage to put in each fund. So, okay, questions? Yes, remind me your name. Jake.
So if we put our equation down here, can we put one of our starting points at our value for that? So instead of the 3/8, 3/8, 0, we put like, one of the starting ones.
Oh, like a 22, 34, 13? So is this a point on the plane? No, because what you're after is, if we wrote this out as an equation, you'd have 22x plus 34y plus 13z equals 21. And a point would be something we could plug in for x, y, and z to make this true. So the 22, 34, 13, if we plug it in there, it's not going to make that true. Yeah. You could pick another point on that line. So if you knew another point on that line, then that's great. So yeah. I just noticed this. I didn't notice this last time, but one solution is not buy any of the real estate fund. Just buy. You can get it by just buying equal shares of this. Is that true? That doesn't seem right. Okay, forget I said that. I don't know. I'll have to figure this out. Okay. Other questions? You guys just all really confused. You don't know what to ask. Yes.
Okay, so when we did this,
Right. Remind me your name. Ben.
So when we did this, like the solution, it's like,
Yeah.
will a set of 3 variables and 2 equations, like, will it always be equal to a line?
So that question is, will a system, just for those online, hold on. Will a system of 2 equations and 3 variables always, will the solution always be a line? No. If they're independent, like if they're different pieces of information, then usually, but we have 2 other cases. X plus y plus 2z equals 5. 2x plus 2y plus 4z equals 10. Here we have two equations and 3 variables, but these are the same plane. So they're not really different. They're not different pieces of information. So there is a solution. It's any point in any of these planes, either of these planes. So because they're the same plane, it's infinite. Now, if I change this to 11, now there's no solution. And if you row reduced, if we row reduce this, 1, 1, 2, 5, 2, 2, 4, 11, if I multiply this by the first row by a -2 and add here, I get 0, 0, 0, 1. And this means, this bottom one means no x's plus no y's plus no z's equal 1, which is It's impossible. Right, the left-hand side equals 0. So that's how we know if there's no solution, if you have all zeros in your coefficient matrix. And you have a non-zero over here. So great question. Okay, other questions? Yes. Oh, nice question. Yeah, I used Z here. Can you use T or S? Yes, and in general we will. In this particular since this is in a context, I would just keep it as Z because it has meaning. It's the number of dollars I put into Z. I put into that fund. But in general, we actually will not write that Z. We'll use T, and this has an advantage. I can describe the same line with T, and this direction vector. If I don't like those fractions, I'm going to multiply everything by 8. So then I get that direction vector. I like that direction vector better. So no fractions. And it still describes the same line. And for every point on the line, for any T I plug in, I get a point on the line. But I can't do that with Z here and Z there. If I keep this as Z, I don't have the freedom to change this. Because otherwise I get, like, if I kept this as Z, now I have Z equals 8Z, which isn't true. So we have more flexibility by replacing this with a T or an S, and usually we will. So nice question. Okay, other questions? Braden. So that question was, is it possible to write the matrix in a different form so that X or Y is the free variable? Mathematically, yes, we can. We could choose to solve for Y and Z and have X the free variable if we want. The convention is, like, if we're getting into row reduced echelon form, we will not do that. So we've all just agreed, it's the mathematical convention that row reduced echelon form follows this pattern where we'll have the leading zero here. I'm sorry, the leading entry here, and it has this, well, yeah, it has this structure. And the advantage of picking a structure like that is that it's unique, and we will all end up with at the same place if we stick with that structure. So, but mathematically, yeah, you could end up solving for Y and Z in terms of X. We won't in this class. I don't think we ever will. We'll stick with the convention of row reduced echelon form. So, okay. But yeah, mathematically you can. Other questions? Okay. That is my bedtime alarm. So let's get out of here and I'll go home and go to bed. All right. Have a great one.